All right, guys, part 2 of transformations. Before we get into what we're doing today, just a quick reminder that if we have a function f of x with 4 transformations, a, b, c, and d, a is going to multiply, because it's on the outside, it's going to multiply the y values by whatever a is. All right, so again, on the outside, it changes the y values, and it's multiplication right there. B is on the inside. It's still multiplication, but it's going to multiply the x values. Whatever's inside changes the x values, and it's going to multiply it rather by 1 divided by b, by the reciprocal of b. Now C. C is on the inside, so it changes the x, so it moves the graph either left or right. And D is on the outside, so it moves the graph up or down. It changes the y values up or down. All right, and then these two would be if it's like a plus C or a plus D, that would move it either left or up, depending on if it's C or D. And then if it's a minus C, you would move it right. Minus D, you would move it down. All right, so using the same thing as yesterday, this question looks a lot more intimidating than it really is. So we have an equation here that's relating two different functions. So we've got g of x, which is transformations of f of x. All right, so we're going to apply these transformations to f, and that tells us what g is. And it tells us that this point is on the graph of f, and it maps to which point, or it becomes which point on the graph of g. All right, so what we're going to do, just like yesterday, we did the entire graph, and we did all the transformations to the entire graph. Now we're just doing it to a singular coordinate point, which is actually easier. All right, and so I'm going to think of it like this. Whatever's on the outside is going to change the y value, and whatever's on the inside is going to change the x value. So let's go from left to right as we do this. So negative 2 is being multiplied, and so we're going to multiply just our y coordinate here by negative 2. So let's start with the y. Y was negative 4, but we are going to multiply it by that negative 2 to get negative 8. Or sorry, positive 8. And then I'm going to jump to the end here because these are both on the outside. We can add 1. It's going to move it up 1. And so our new y value is just 9 when we do those two transformations. Now let's do the x transformation. So we started at x equals 2. We're multiplying by a half, but remember, inside is opposite, so it's the reciprocal. We're going to multiply by 2 over 1, or 2, to get 4. And then we're going to take 4, we're going to move it right 2. So that minus 2 will actually add 2 to the x coordinate and put it at 6. And so the new coordinate point is going to be 6 for x and 9 for y. All right, so again, the 2 on the outside change the x or the y value. This one by multiplication, this one by addition. The 2 on the inside change the x coordinate. We have to flip this one and then change that sign from a minus to a plus. All right, so that's the new point on the graph. It just changes those two. All right, one more example. This time we're going to do it, I'm going to give you the domain of a function and the range of a function. Now, I gave this one as an interval and this one as an inequality. It's the same thing. I could have done this 6, 12, or I could have done this one negative 2 is less than or equal to x is less than or equal to 4. But I just mixed up the notations here. All right, so we have the domain of a function and the range. Remember, domain is always x, range is always y. Now we've got a new function, j of x. So before it was h of x, now we have j of x. And j of x is a series of transformations on h of x. So we're going to figure out the domain and range of this new function, j of x. So again, whatever's outside is going to affect the y's. So it's only going to affect the range, whatever's outside. Whatever's inside will affect the domain. All right, so I'm going to do the 2 on the outside. I'm going to start with the times 3. So we're going to take our range here, which was 6 from 6 to 12, and we're going to multiply both of those by 3. So the 6, we're going to do times 3 to get 18. And the 12, we're going to do times 3 to get 36. All right, so that takes care of the times 3. Now we're going to do the other one that affects the y's. That's the minus 10. So we're going to take the values we just got, And we're going to subtract 10 from both of those. And these are the values of our new range. All right, so the minimum value is 8, and the maximum value is going to be, what was it, 26? 26. Okay, so that's our range. Domain, again, the inside is going to affect the x. So times 2 actually means we have to flip it times a half. So we're going to multiply both of our x coordinates by 1/2. So -2 times a half gives us -1. And 4 times 1/2 gives us 2. All right, so multiplied by the reciprocal of that number. Then remember, +1 is really left 1. That means we want to actually subtract 1. So we're going to subtract 1 from -1 to get -2. And we're going to subtract 1 from 2 to get +1. So our domain, again, I took that first x value, multiplied it by a half, and then subtracted 1, and I got -2. And then same thing, I took the second x coordinate, multiplied it by 1/2, then subtracted 1, and that gave us 1. All right, so that's our new domain. So it's really kind of the same thing we were doing yesterday, just instead of having a whole graph, we're just getting some pieces of information about the graph, but really doing the same process. We're, again, multiplying the y's, multiplying by the x's by the reciprocal, moving it left or right, moving it up or down. All right, that's it, guys. Stay flawless.